In our previous step, we have got our three differential mechanical rotational equations over there, and these do require some little bit modification for our given equations over here. This one should be our d2 theta t divided by dt2, and rest of the equation will be same over here. So we no longer do require to have this given circuit diagram over here, as we have already formed our differential equation for our mechanical rotational system over here. So we can do enlist our given equations over here to have some more space. In our next step, we do require to convert this rotational mechanical equation into our electrical one over here to form the diagram for our electrical circuits over here. So let us go for that consideration. Okay. So to have some more space, this one is our first equation and this one is our equation 2. This one is our equation 2. This one. And I'm just going to write down over here the equation 3, which is J3 d2 theta t divided by dt2. I have got a silly mistake over here. So this one should be our d2 theta t divided by dt2, and I have written over here plus our b3 d dt of our theta t 3t plus ultimately our k2 multiplied with our theta 3 minus of our theta 2t, which is ultimately equal to 0. So this one is our equation 3. Okay. Now in our next step or in our next part of our consideration, we do require to convert this mechanical equation into our electrical one over here, and we are going to utilize this chart. But before we go into that, we do require to construct some important relations or important consideration for our electrical equations or for our mechanical equations over here. We have do know that according to our analogous chart, we have got that the angular displacement theta t is equal with our charge, which is our qt. Now if you do take the derivative or single derivative of this consideration, what we have got d theta t divided by our dt. So if you do take the derivative of the another side of our expression, so we do require to do the same for our another part of our equation as well, which is our dqt by dt, and ultimately this one is our omega t, which is the exact definition for our angular velocity, which is our omega t. So quite naturally this is our omega t, and this one should be our, according to our definition, we do know that the rate of change of charge with respect to time, that actually lead us to the consideration as our it. So it is our dqt by dt. So this one is our first recognized expression over here, and in our next part we have got, according to our definition, we do know that dqt by dt, which is our it. Okay. Now if you do consider or rearrange our given expression, we have got our dqt, which is our it dt. Now if you do take the integration on both sides of this given relation, we have got integration of our dqt, integration of our it dt. So ultimately integration of dqt means our qt. So qt is our integration of our it dt. Okay. So this one is very important for our consideration for our relation over here, and we do require to remember these two relations over here. So the first relation will be our d theta t by dt, which is the dqt by dt, which is ultimately our it. Okay, so this is our first relation. So the first relation will be our dqt by dt, which is our IT. This is our first relation, and our second relation will be our QT, which is nothing but integration of IT dt. Okay, so the QT is our integration of our IT dt. Okay, so these two relations are absolutely important for our consideration, and we do require to consider or put or do require to convert this given mechanical rotational equation into our electrical one over here. So before we go for that chart consideration over here, we do have formed this relation over here, and I do require to repeat this portion once again. Theta t is equal with our qt according to our given analogous chart, and if you take the derivative on both sides, we do have d theta t by dt, which is ultimately give us the omega t, and this one is the definition of our it, and according to our definition for our current, dqt by dt is our it. Now how do we get to that point for our qt? We have just rearranged our given expression, and if you do take the integration on both sides, we have got qt is which is equal with our integration of it dt, and I have written these two relations over here because these two relations are absolutely important while converting our mechanical equations into our electrical one over here. So let us go for that conversion for our given equations over here. So just go for our first equation, and if you do follow that first equation, what we have got, the torque is equivalent with our voltage of our et. So at this place of our torque, I am going to use as our et, that is our voltage, which is et. The J1 is analogous with our inductance L1. So this one is our L1. D2, our theta means our charge, which is our Q1T divided by our DT2, plus B1 is analogous with our resistance R1. So this one is our R1 ddt of our Q1T. Okay, plus once again the k1 is our 1 by c, the stiffness is 1 by c, which is 1 by c1, and theta 1t means our q1t, the angular displacement, which is equivalent with our charge, which is inside our bracket we do have our q1t minus of our q2t. So this one is our first electrical equations over here. So we do require to follow the same procedure over here. So for our next equation, which is our equation 2, the J2 is analogous with our inductance L2. So at this place of our J2, we are going to utilize as our inductance of L2 over here. So L2, our D2, at this place of our angular displacement, we are going to use the charge Q. So D2 Q2T divided by our DT2 plus B2 means our R2 ddt of our Q2T plus K1 is our 1 by C1, and inside our bracket we do have our Q2T minus of Q1T, and once again for our K2 we do have plus 1 by C2 theta 2t minus of theta t3, which actually implies that our Q2t minus of our Q3t, which is ultimately equal to 0. So this is our second electrical equation over here. Okay. In our next part, we do follow the same procedure for our equation 3 as well, which is this one, which is J3. So at this place of our J3, we are going to utilize the L3. So this one is our L3, and quite naturally D2 theta 3t means our Q3t divided by our DT2 plus B3 means our R3 d dt of our theta 3t means our Q3t plus K2 means our 1 by C, So this one is a 1 by C2, and at this place of our theta 3t minus of theta 2 3, we do have our Q3t minus of our Q2t, which is equal to our 0. So this is our third electrical equations over here. But just by looking at these three different equations, just we have utilized according to our force voltage analogy, these three electrical equations are not look like our given electrical equations over here. So we do require to further modify our given equations over there, but that I will do for our next part for our consideration. I want to repeat this portion once again. So there is one equation for our mechanical one that will be converted according to this given table, and we have converted this equation 1 into our equation 1e. 1e actually signifies as our electrical equation 1. Similarly, for our equation 2, this is our equation 2, we have followed the same procedure. Just by utilizing this analogous table, we have converted this mechanical equation of equation 2 into this 2e over here. And similarly, for our third equation, we have followed the same procedure and have converted the mechanical equation into our electrical one just by following the same table over here. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos, and keep following our channel. Just wait for my next part.
If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.